A very fine good afternoon to all of you. Today we are going to discuss about lecture 28. So today we will discuss about a very important topic, that is density based clustering algorithm. Okay. So we also called it DBSCAN. So unlike K-means, and DBSCAN does not require us to choose the number of clusters beforehand. Instead, it groups data based on density, meaning areas where many points are close together. It can also identify noise or outliers, which K-means cannot do. So DBSCAN works well for complex cluster shapes and real-world data. So what is the actual concept of DBSCAN? Now we should know that. First, epsilon is the radius that defines the neighborhood around a point. Then we have minimum points required, that is MinPts, to form a dense region. A core point has enough points within its neighborhood. A border point is close to dense region but does not have enough points itself. And noise points are outliers that do not belong to any cluster. So here we will see the things in a very detail after some time. First, let us go through the theory part. Okay, so how does it work? So let us understand how does DBSCAN works. First, we pick a random point, then we check how many points are within its neighborhood using EPS. Okay, if the number of points is greater than or equal to min points, it becomes a core point and forms a cluster. Then the cluster expands by including nearby core and border points, and this process continues until no more points can be added. Finally, any remaining points are marked as noise or outliers. Okay, so here we can see, okay, here you can see that DBSCAN is a density based clustering algorithm. It groups points that are close together and marks isolated points as noise. Okay, then here we see cluster formed based on dense region. Points that are far away from the cluster are marked as noise or outliers. Unlike K-means, we do not need to choose the number of clusters. Okay, then the circle represents the neighborhood. Okay, so wait a minute. So these are the noise points. Okay, that is away from the cluster. So the circle here, it represents the neighborhood defined by EPS. Min points is the minimum number of points. Okay, minimum number of points required inside the circle. Okay, minimum number of points required inside the circle. Core point has enough neighbors, that is dense area. Okay, then we have border points near a dense area but not dense itself. And then we have finally the noise points, isolated, not part of the cluster. Then you can see how DBSCAN works. Okay, it first we pick a point. Okay, then we check how many points are within its EPS radius. Okay, if it has enough neighbors, it becomes a core point and starts a cluster. Okay, then the cluster expands by adding the nearby points. You can see here, and this continues until no more points can be added. Okay, and then remaining points are marked as noise. Okay, so you can see here how well it is explained over here. And this section basically shows how the cluster groups grows step by step. We start from one core point and then expand to nearby points and include borders, and then finally we complete the cluster. So DBSCAN finds dense regions, expand clusters, and labels isolated points as noise. It can detect complex shapes and outliers which K-means cannot actually handle. So DBSCAN is very important. It can come in your interviews and your semester examination. Now we'll discuss about what are the advantages and disadvantage of DBSCAN. Okay, so one big advantage is that we don't need to choose the number of cluster in advance. It can also detect noise or outliers, which many algorithms cannot do. And it works well with complex non-linear cluster shapes. However, it has some limitations. Choosing the right value for EPS and min points can be difficult. It may struggle when clusters have different densities, and its performance is sensitive to parameter selection. So while DBSCAN is powerful, it requires careful tuning. Coming to the conclusion part, okay. So DBSCAN is a density-based clustering algorithm that groups data based on the dense region, okay, as I have explained in this slide. And it can detect noise and does not require us to choose the number of cluster. In the next lecture, we will try to learn PCA, which helps us to reduce the number of features while preserving the important features. I'm really grateful to all of you for coming till this part of the video. If you have watched the video, do share your point of views on the video. Do you like it or not? I have also added quiz so that you can learn in a better way. So continue your machine learning journey and learn it in a very better way. And I'm really grateful to all of you. Kindly support us and thank you so much to all of you.